Okay, everybody, we're going to take a look at balancing equations using the hanger balances. Now, we have been working with the illustrative math, and we've been having some good conversations in our warm-ups and think about it about balancing and how we know in this situation that triangle has to be heavier than square because the balance is not balanced and it's tilting heavier to the left there. But we look at B, we see that triangle has to be equal to 3 squares because the scale is balanced. And we plugged in a few different equation numbers for these equations, and we said triangle could be 30 and each square could be 10, and triangle could be 9 and each square could be 3. The point is we're dividing it by 3, so whatever triangle is divided by 3 would be each square. So we're going to take a look today at solving some equations. So I have a few that we're going to just kind of do together so that you can see if in case you were absent or maybe you just need to see it again. All right, so our first one here, we see that we have a y and we have two 4's. So our equation is on one side of the expression equation we have y, and on the other side we have a 4 plus a 4. Now another way to represent this would be 2 times 4. So y is equal to 2 times 4. And that one was pretty easy, right? Y in this case would have to be 8 because 4 plus 4 is 8. So therefore y is 8. And if we plug y in, it checks out. So that was a pretty easy one. The next one, though, is a little more complicated. So for this one, we have to do some balancing. For those of you who are pretty good in your with number sense, you can probably figure this out, but I'm just going to replicate it on my paper here. I know I have an A, and I know I have a 3, and on this side I have a 7. So what I would get into the habit of doing is writing an equation for your picture. We know this is the equal sign, and on one side we have A and a 3. This is not A times 3, this is A plus 3. I have one A and I have one 3, and on this side I have 7. Okay? Now, we can probably use our number sense to figure that A is 4. Many of us are pretty good with that, but let me show you the steps so that way when the numbers get larger, we have a process to figure out the missing number. All right, so we know that our equation is A plus 3 is equal to 7. So what I can do is I can remove my 3. I can actually take my 3 off the scale. If I take my 3 off the scale, my scale is going to tilt down towards the 7. It's going to be off balanced, which is expected. If I took a 3 off of a scale and I left just the one weight there, they're not balanced anymore. So I have to also take 3 from this side as well. So mathematically, we are creating what we like to call a zero pair here, because a 3 minus a 3 is 0. It's no longer there. All we have is the A. And on this side, we're taking 7 minus 3. We're taking 3 away from both sides because remember, we have to keep the scale balanced. If I take 3 off of this scale side, I have to take 3 off this side. And that leaves me with leftover of 4. So we can conclude that A is equal to 4. And our new balance scale will kind of look like this. I'm just going to do a quick sketch. We'd still have our A, and instead of 7, we would have 4. Now, how can we test this out? Well, all we have to do is go back up to the beginning. Now, remember a couple lessons ago, we did this where we substitute. If A equals 4, is the scale balanced? Okay, so let's plug it in. If A is equal to 4, does 4 plus 3 equal 7? Question? Yeah, it does. And I could check with a calculator too just to make sure, but A is equal to 4. Our scale is balanced. And in our Desmos, I can type in 4, and there it is. The next question is great because then you find the equation. Now, we already wrote the equation because remember, I told you, get into the habit of writing an equation as soon as you see your picture. So I'm looking for A plus 3 equals 7, or 3 plus A. I can do the commutative property, or I could start with the 7. But if I look at the picture exactly how it's represented, it's A plus 3 equals 7. Voila, there it is. All right, let's try this one. This is a good one. All right. So for this question, again, I'm just going to do a quick replication of the equation. All right. And I have a W, and I have a 6. And over here, I have a 5, and I have a 5. All right, remember what I said, get into the habit of writing an equation. So what do I have here? I have a W plus a 6 on one side, and on the other side, I have a 5 plus a 5. Now, I don't know about you, but as soon as I saw a 5 and a 5, my brain put it together and said 10. That's because you have been combining like terms since you were in like first or second grade. We've been doing this for a long time. As soon as you see those two numbers, you just put them together. So we could simplify it and say W plus 6 is equal to 10. Because 5 plus 5 is 10. So you can just kind of fix that right away. All right, so again, you probably are saying, Miss Breen, I know what W is, but let's do the math. Let's prove it. Let's take 6 away from both sides of my equation. Okay, I'm just taking away the 6 off of the scale. Again, there's that 0. Okay, he's gone. We took him off the scale. But in order to keep it balanced, I have to take 6 away from this side as well. What I have left is a W, which is what I want. I want my W by itself so I can figure out how much it weighs. And over here I have 4. So we can conclude that W equals 4. Again, let's try it out. Let's go back to the original equation. Let's substitute 4 for W. Okay, 4 plus 6 is 10. And guess what 5 plus 5 is? 10. So we have 10 on both sides. It works out. And here it is, balanced. Go over here, W plus 6 equals 10. All right, so we're going to take a look at some more challenging questions. I'm going to skip ahead and let's take a look at this one. Okay, so now we have a different type of equation. These have been addition, W plus 6. 5 plus 5. A plus 3 is equal to 7. Now we're going to get into a different type of equation. So I'm going to create my little balance scale. And again, even at home with paper, you can do this. Just draw a little balance scale. I have an H, and I am not going to draw that pentagon. I'm just going to draw circles. I have an H, and I have an H. And then on this side, I have a 6. So what do I have here? Remember I said always write the equation. I have an H plus an H, and that equals 6. Another way we can say this is how many H's do I have? How many are here? Well, there are 2 H's. This is another way that we can represent these variables. H plus H is the same thing as 2 times H, which we can just say 2 H's. And if you think about it, it makes sense, 2 H's. 2 what make a 6? Well, what we're doing is dividing, we're splitting. We see we have 2 here, so I can just split my 6 into half. 6 divided by 2 equals 3. Now, let's look at it mathematically. 2H equals 6. If I divide both sides by 2. I divided this by 2. I divided this by 2. 2 divided by 2 gives me 1H because 2 divided by 2 is 1. And that leaves me with my 1H. There's my 1H. See how I split it in half? So there's my 1H. And now 6 divided by 2 is 3. Let's go in and plug it in and test it out. 3 plus 3, 2 times 3. 2 times 3, or we could say 3 plus 3. Is that equal to 6? It sure is. Okay, so it balances out. And we can check it on Desmos. 3, it's balanced. And then the next question is telling us to look for the equation. All right, so 2 H's equals 6. Look for 2 H's equals 6. There it is. Be really careful with this because a lot of kids want to pick divide. Yes, we did divide. That's what we did to figure out what H is. But the original equation is 2 H's equals 6. 2h equals 6.